Another important point in thermodynamics is to understand the state variable and the path variable. As we know, when the state of gas from P1, V1, T1 is changed to a new state which is P2, V2 and T2, corresponding to a given thermodynamic process. And obviously for this process, the process equation is given as P equals to F of V. Then the thermodynamic parameters involved in the process are heat supplied, work done by gas and change in internal energy. If we plot the indicator diagram for the process, say it is plotted from initial state S1 to the final state S2. Work done can directly be calculated as the area under the curve from initial volume V1 to V2. This area we can write as work done by the gas in the process. And as we already discussed, for the two given initial and final states, there can be infinite kind of curves we can draw to join these 2 points. And corresponding to each curve, there will be a specified thermodynamic process. And for a given thermodynamic process, if curve is different, obviously the area under the curve will also be different. So we can directly state that work done by gas depends on the path from initial to final state. And when we talk about internal energy, we already discussed for any given state, delta U can be written as NCV T2 minus T1. It does not depend on the way how the process is being executed. It depends only on initial and final state. So by first law of thermodynamics, if we just analyze, we can say Q is equals to delta U plus W. The amount of heat supplied is the sum of increase in internal energy and the work done by gas. Here we can see delta U remains same in all kind of processes, whichever path you follow. If there is one and say it is changed by a path 2 or it is changed by another path 3. In all these cases, we can say work done would be different, but change in internal energy, as it is only dependent on initial and final temperature, it will remain same because temperature at state 1 is T1, at state 2 is T2. No matter whichever path is being followed, change in internal energy will be same. So this delta U does not depend on the process, but we can see work done depends on process. So obviously when we calculate the sum of these two, this Q will also depend on path of process or the specific thermodynamic process. If it is changed from initial to final state, the total amount of heat supplied will be changed. So just now we have seen that the amount of heat supplied and work done by the gas depend on path. So these are termed as path variables. And the change in internal energy for a given thermodynamic process only depend on a state, so this is termed as a state variable. So we can also state if a gas state is changed from P1, V1, T1 to P2, V2, T2, there can be many ways. Mainly we are talking about thermodynamic processes. There can be many thermodynamic processes for this. And in all processes, we will be having, you can write change in internal energy will be NCV T2 minus T1. So we can always write that it is always same. no matter whichever process is followed, the change in internal energy will remain same, and Q and W will be different for each process, such that if we find out the change in internal energy in a specific process 1, so it can be written as Q1 minus W1, for another process it is Q2 minus W2, and so on. Thus, for all processes, if in one process the gaseous state is changed from here to here, heat supplied as Q1, work done as W1, their difference will always remain constant. So as W is changing for all processes, Q will also change such that their difference will remain constant for the two given processes. That's why internal energy change is termed as state variable, or even internal energy is termed as state variable, and heat supplied and work done can be written as path variable.